Section 8.2, Types of Mechanical Waves. Mechanical waves are either transverse or longitudinal. A transverse wave is a wave in which its particles vibrate perpendicular to the direction of the flow of energy. Perpendicular means at 90 degrees to. Examples of transverse waves include water waves, the pendula of a clock, and a slinky that moves in the transverse direction. If we see the rest position in a transverse wave, we can see that motion starts at 90 degrees in either direction from the rest position. So the wave is moving back and forth in this direction, while the length of the medium is in this direction, and this way we have a perpendicular vibration for the flow of energy compared to the medium. A longitudinal wave is a wave in which the particles vibrate parallel to the flow of energy. These two definitions for transverse wave and longitudinal wave are almost identical, except in the direction by which the particles vibrate with respect to the flow of energy. Here we have a mass attached to a pendulum, and if we allow that mass to rest, its equilibrium position would be this point right here. Now, the medium itself goes in the up and down direction, and this vibration, because of the string's elasticity, can cause the wave to move up or to move down in a direction that is parallel to the flow of energy. Therefore, when a vibration of particles is parallel to the flow of energy, we call it a longitudinal wave. Sound is our most famous example of a longitudinal wave. A vibrating object can produce longitudinal waves in a part of the medium that it surrounds. If these waves have properties that make them detectable by the human ear, they are called sound. Sound is defined as a form of energy produced by rapidly vibrating objects detectable by sensory organs such as the ear. The way by which most waves are transferred is more complex than we'll study in this unit. However, we're going to study a more simplified version of the way waves ideally transmit, are propagated, and interact with each other. This will allow us in the future to study more and more complex wave motion. Transverse and longitudinal waves are basic types of waves. However, in many cases, these waves combine to form more complex wave. For example, water waves on a surface of a lake are largely produced by wind. The wind will impact or impart some longitudinal motion to the water molecules, resulting in a motion of the water molecules that is oval in shape. The shape of the oval is controlled by how much molecules move in each. I want you to try homework questions on page 384, numbers 1 to 9. Good luck.